Hello, and in this part we're going to unwrap and texture the model. So here I have my core model. What I will be doing for texturing is I'm not going to fully unwrap the whole model. I'm going to cut the model in pieces so we save on UV space. So I will be cutting out pieces of the model so I don't have to have a fully unique texture for everything. So for example, we can cut it in half so I don't have an unwrap for everything. There are of course some other ways we can texture it, like you can use styling textures, material IDs, trim textures and so on. But right now I want a unique texture for it, but also save enough UV space for it. And this time let's start out with building the low poly first. So in my other videos I always start building the high poly, but now I'm gonna start building the low poly first. What I will be using is a voxel, the voxel measure, and let's place it in here. So it's gonna merge everything together in one big shape. So we can also see that there is inside, it's all one big shape now. Now we can increase the detail and the smoothness by going into, for example, a custom resolution and start lower depending on what you would like to need. So I'm only going to use this for my low poly, so I'm not going to worry too much about details. And I will be reducing this with the poly reducer. And now we can start specifying how much polygons you would like to have. If you would like to see your poly count on screen, then press D when your mouse is in the viewport, and then we go to guides and then show geometry information and go here to always on, and now we have the amount of primitives and points. So let's say we want 2%. So this take a moment. And so now we have around 11k. So that should be okay. And like I mentioned before, I will then cut out the sphere into pieces. Like, for example, this. So we only have 1/4 of the ball that is uniquely textured, and then I will be copy pasting this part so we have the original shape back. So you can play around with where you would like to have this. So maybe you want this part to be unique, and I think I will be going with this piece. I like this piece. I will be using this piece to be uniquely textured. Now I want to create a high poly, and I will be showing a different way of doing this. So normally what I did is I would just use a voxel, and we can already see that it's going to create this high poly feeling in there where we can control the smoothing. So that was my approach I normally do, but I also want to show you a different approach. And in this approach we're going to use the round edge shader. So there is a shader that will create automatically round edges, and we can bake this in a normal map. Now to do this, an easy way is by using the quick material in the labs. So in here we have our side effects labs quick material, and if we go here to the settings, under normal we see round edges. So enable this and fill in a low value. Now to preview this result, we're going to have to temporarily render this out because this is not active in the viewport. So what we can do is we can go here and to a render region. So we can select a certain region that will be rendered. And as you can see here, it's now rendered, and there is definitely some smoothing going on here. Maybe it's too much. So this can be a usable result. There are a few tweaks I did. So first of all, I added a normal here above because that seems to help a lot with the round edging. So I set it also to face area. So that helps a lot with geometry. You can see that we're going from a quite low poly shapes into a nice round nice round shapes. And also I made an environment light here. This helps just with having a nicer view in here. So that seems okay to me. So we also saw here a lot of artifacts going on, but when we do the temporary rendering here, it seems to be solving actually really nicely. So as you can see, it actually solved this complex situation into a better geometry. Now we can also just fix this issue by going back here where we originally create this topology, and then we can start, and then we can, for example, increase the divisions, which helps with constructing these areas. Or maybe we have double points in there. If I would check the poly count, we have a lot of overlapping points. So if we would do a fuse, that also might help reconstructing that area. Like this. So it's cleaner now. So also here, so this will be then my high poly. I will also assign some material IDs, and I will be using these colors I used for viewing these material IDs, and I will place them behind here. So these are then material IDs. Let's then also store them in the primitive, so we can keep them in the primitive. This should normally not affect the baking. If you would store the color in the points, they would like bleed to the other point. One little tweak also we need to do in the color is we need a solid background color, and I'm also going to store it in the primitive. So in this case it's white, but we can also just use the 0 or black. Then I also have these parts that I also want to unwrap and texture. So I will be going up here. So we'll be only unwrapping one of them, and I will use null nodes out detail 1, and this detail I'm going to use it here, object merge, and I will be using the out detail. So I'm using this object merge node to not create a mess with my nodes and lines, so it's a bit structured. And I need to merge this with the high poly, of course, so it's included in the high poly. And let's see how my high poly then looks like. So we have our core with and in the inside there is this model floating around. And I don't think we have material IDs set on this one. So if you also want certain glowing parts or certain panels colored, then you can also set up a material ID for this one as well. Then for the low poly, I will be doing a similar process here. So I'll be first using a voxel. So this will merge all the pieces together in one big piece. And then I will be using a poly reduce. And then I can decide how much polygons I should spend on this. And we can also use the output polygon count, and we can fill in specific numbers. So right now we have 1000 primitives that is being used to construct this. But we have, I might go a bit higher, maybe 1500. And you can also play around with these other settings, like using original points. So we'll use original points from the input, or this can also be a quad reducer. As you can see, it's going to keep all the quads that we had from the voxel and try to reduce them. This doesn't necessarily work well on hard surface and on very low poly counts, so I'm going to triangulate this. And I'm also creating a group, and I'm going to save this information in a group and call it detail. So later on, If I merge these two together, I can always ask the information back. So then I use a auto UVing, and we look at the unwrap, and we can play around with these settings. And I'm going to use the UV unwrap. So definitely check out other features from this auto UVing. So then I'm also going to use the soften normals. And I'm going to use the hard seams. And then this is then my result that is ready to bake. What I also would often do is I would lock in this result. So when it's locked, it means that nothing will be able to change this node. So it stores all the information in here as well. If I even delete this line, we can see that it is missing this input, but it's locked, so it keeps the information in the node. This has the advantage that it doesn't need to be recalculated every time we make a change. So now it's saving this UV and it doesn't need to be recalculated. So now let's do a test bake, and we need a baker for this. So normally I would use the maps baker, which is a really great baker and also fast. But since we are working with the round edges, the maps baker currently is not supporting it. But we have the other baker, which is the simple baker. So this one is a little bit slower, but supports the round edges. So we're going to fill in the low poly and high poly. And then we can start baking my maps. So what I need is, of course, a vertex color, normal map, AO. I would also like the curvature. And I'm also going to increase the resolution to 2K. And to automatically store the files in here. And I will make this a PNG. You can also decide to, for example, use the maps baker, but for other maps, like for example the color map, you can also just render this out in here, so you don't have to bake everything in here necessarily. So let's test it out, and we're gonna render this out. So this will bring up this menu for baking, and this might take a moment. So this is then my result, the normal map from this model. We can also quickly either use a quick material or quick shade to view the texture in Houdini. I also noticed the mistake here that this piece, when I view my AO, is then completely black. So I will be fixing this, but otherwise all the maps look decently baked. So to solve this problem, instead of putting the piece in the middle here, I put it outside the sphere. So the reason was that this detail piece was inside the bowl, which of course when we bake the AO will be resulting in a black piece. So in here I put a transform and I filled in a constant value 2 and I moved it up by 2 units. So afterwards I'm gonna have to move it 2 units down to put it back in the original position. But as you can see now, it baked the AO correctly. And now we can move on to texturing, and I will be using the Substance plugin for this. Before we can start using Substance in Houdini, we need to of course make a Substance file. Here's the setup that I'm using. And the important thing here is that we can use an input node to import custom maps, to import custom textures. So if you just type in input, you have the option for a color or a grayscale. So these nodes are used to import maps from Houdini. And you don't need to fill in any special names except here for the identifier. Make sure you fill in names you would remember. In my case, I have inputs for normal map, AO, curvature, and the material ID. So you can build it more if you want to. And I start here a network to define more the material. This is not a super complex system, and I also used some pre-made materials that are in Substance. For example, if you just type in metal, you have some presets for metal, so you don't have to start from scratch. Also, for example, for edge damage, you can use the metal edge wear, for example. So I used some built-in features from Designer to quickly construct a material. So once you got your material set up, you're gonna then need to publish this element. So by clicking on this icon, you can start publishing this material, and this file can then be opened in Houdini. In Houdini here we have these maps baked out to use. Then I want to access the substance plugin, and this can be found in the COP network. So I will be creating a COP network. So in here, if we then type in substance, we have the substance plugin available. So then in here, you fill in the reference to your substance file, and then it will load the substance file. And we can also build further custom parameters if we want that. So how do we now use our custom files? So we're going to use a file node here, and in this file node, we're going to search for our textures. So we need our normal map, and I'm going to copy this node, and I'm going to do this for the other ones. So curvature, AO, and or color ID. So these are then our 4 maps that I want to input here for these. So also what you can notice here for the color is that it's quite dark, and we actually need to boost the colorness. So I'm gonna here fill in 2.2, so it's a better color. Then here the important part, if we would plug in this map here, it is not going to work. And the reason for that is because we are looking for the plane that is called normal. But in here, if I hold the middle mouse button, my plane is called C. So we need to change this name from C to normal. So we're going to use the rename node. And with this rename node, we can then fill in C here and then fill in the normal name. So if I would do this, we now have transferred the normals in there. And I will be doing this then for the other planes as well. So here, curvature. So then I merge these together by holding the Alt and merge them together. So if your naming is fully correctly done, we should see here our result. Now we can also here go to the composite view, and we can then see our texture. So I can see it is working. I can also switch to normal, metallic, roughness, and so on. I can cycle through the maps if I want to. So now we have the setup ready to then finalize our texture, and based on how much parameters you make, you can then, for example, increase the intensity of, for example, awareness and edge damage there is. Like in my case, there's some little damage going on. Also notice that the resolution is also 512, so it's not that high quality, but we can increase that. So let's say you're happy with this result and you want to export these images. So for that, we're gonna need the output file. So this is a node that can output these files. And here I will fill in a place to save the files. And the first one that I'm going to export will be the color. So let's plug in this part over here. And what I need to export is not the C, because C actually doesn't exist. We need to export the plane called diffuse. So let's call diffuse in here. And also we need to only render current frame. So press save now, and I can go back here to this network, to my scene view. In this case, let's use a quick shade to then check our texture. So this is then my texture. So we're going to repeat this process then for all the maps we need. So we can also give this a name. So this is the color. This can then be the normal. And there is also an invert function here. If you need to invert the normal map, depending on the game engine you use, you might need to invert the result. So you can always do that here. And instead of filling diffuse in here, we're going to use normal, and also the naming normal. Then if we are going to use Unity as our game engine, then we need to build a custom texture that merges the metalness, ambient occlusion, and smoothness in one map. So for that, I'm going to do a different approach than just simply exporting it. And I need to build a small network here for that. First of all, let's delete these maps that I don't need for it. So in here, I wish to only see my metalness, for example. I can go here in metal and click non-scoped planes. So I only see my metal map. Then I can do the same for the roughness map. So I have extracted the roughness, and then I also need the ambient occlusion, but I already have it here. I calculated this here. So I will just use a null node to place it here. So we have now the metalness, roughness, and our ambient occlusion. So to merge these maps together, I'm going to use a VOP cop filter. And I'm going to plug in then the metal roughness AO in here. And let's go in this map. And to get the information, we can actually use input, cop input node. This directly gets the information from input number 1. So I need this 3 times. So this will then be index number 1 and then index number 2. So this is my first input, second input, and then third input. Then I also need to convert this vector to a float. So I'm gonna type in vector to float. And we need in our red channel, we would like to have our metalness. Then in the green channel, I would like to have the occlusion, ambient occlusion, and then the smoothness is then here in the alpha. There is also a blue channel, which is used for the detail mask, but since I'm not using that, we can use a constant to fill in that value if you would like to. So you can just simply plug that in here, give it, for example, a value 0. Now we can also notice something weird going on here. We have this big piece, and the reason for that is because my ambient occlusion is actually a different texture size. This is a 2K size, which I'm using a 512. So either we increase our resolution, which could be a good idea to have a higher resolution, or we can also use the scale node. So with this scale node, we can set it to resolution and fill in custom resolutions. Like for example, we can make our AO 512 by 512. And then if we fill this in here, we have now the correct results that we would like to see. Also, one little thing here is we need to invert the roughness because Unity works with smoothness. So invert the roughness here. And then same as we did here, we can then use an output node and then export the result, which is called here metallic in our case. And also using the alpha from the metallic. And I'm going to call this the mask map. Let's render that out. Then one more map I want to export is actually the emissive, because I added in Substance I added the next substance, I added the emissive option, so you can export the emissive parts. So in here, emissive channel, so we have made this setup. If you want to export all the maps in one click, we can select all 4 of them and just click render, and Houdini will render all 4 of them at once. So the texturing is then done, and I would like to reconstruct back my model. So first of all here, I'm gonna split my model back based on the detail. So my detail is separate and my core model is also separate. If you remember correctly, we moved up this piece by 2, and I'm gonna also move it back down by 2 units again. So -2. So it's back here in the correct space. Then this part plays down a null node, and we're gonna reference this back to the original place. So out detail, and this is then the final low poly, and I'm gonna reference this back here, object merge node, and filling in the out detail low. You can clearly see here that we took our geometry, we unwrapped it with the other part, and then we call back the geometry with the correct unwraps. So they all share now the same UV space. Then going back here, and with the other input I need to mirror the result, or you can also use the symmetry. One of the two will do the job here. So you can mirror the result and then mirror it once more to then have this look. So then I need to get back these details on top, and of course they are not gonna fit properly anymore because we cut 1/4 of the model and we mirrored the result. So now I'm going to extract the pieces that will fit on this panel. So in here I'm gonna click these pieces that I want to use. So for example, these are the 4 pieces I would like to see on my model. So I'm going to press delete and invert the selection. So these are the only ones remaining. And I'm going to copy paste what I've done here, these mirrors, to here as well. So we have the same result. And I can also notice that here in this situation we have these overlapping parts. So if you like them, you can keep it, but for now I'm going to simply click them and click delete. So also on the other side I'm going to click it and delete these. So you can find a more procedural way of doing this, but for now I just want to have my result. Then I'm going to bring these and these together, and let's see how my model looks now. So this can then be the result you want to have for the game. So now let's export this, and there are multiple ways of exporting. For example, here we have file, export, FBX for example. Now I barely use this one actually. I use the other ways, and they are FBX nodes. So in here we have a FBX node in our sub level. So I can use this to output FBX files. But we can also go back here to the output level, and we can also use an FBX node here as well. Mainly use an FBX node here in output level if I have to export multiple objects and not only in subs. So let's go back here to my object and then export it. So we can link in this model, so it will export the result. And what is also important is to place down a null node here, and this will be the mesh name. So we can, for example, core model 01. This is then the model name that we can see in Unity. So here I'm going to directly save this then into the Unity project. So as you can see here, I directly put it in my Unity project so I can quickly see the result and go back and forward. Then we are here in Unity and I have my model and I can see it's super small. So either we can crank up the scale here or we can go back and forward with Houdini. So I can use transform, set it to 100 and start putting it in the right scale, as you can see. Then I'm also going to import the textures. So in here, let's import these textures and let's see how they are looking. And this is then, for example, the result already. The core is almost finished, and I can then see actually here an issue where we can see these lines going on. Like here, for example, these weird lines, also here on these areas. So the issue here lies actually within the normal map. So if I here take my better normal map, we can see that the lines are actually now gone. So there is a small tweak we have to make in the network to output the normal correctly. If you also look here in the Unity project, you can also see a little bit color difference from this is the correct one and this is actually the wrong one. So there is a little bit color off in this one. So you can definitely see that this is definitely a wrong normal map. So we have to tweak the COP network. So to demonstrate what the issue is, I'm gonna render out here my normal map. So this is the baked normal map. And here after the substance node, I will use a delete and I will only be filtering out the normal map. So if I hold shift now and also render this one out, you can compare the two results. And immediately you can see that this result from the delete node has a way different color than my originally baked normal map. So we have to be careful with this information. So the color should definitely be more like the original baked one, because this is a wrong information. How we can fix this is we need to fix the gamma. So in here what I did before going in substance, what I did is I added some gamma and I brought it to 2.2. Then afterwards, we have here our normal map, and I brought the gamma back with a 0.45. If you would be wondering why this value, if we use 1 and divide it by 2.2, we have then actually this value. So this will bring the normal a bit to a better result. So if I would compare the two now, we can see that they are somewhat more equal. So if I go here to the same region, they have somewhat similar colors now. Of course, this is a way lower resolution. This is a 512. We are comparing it with a 2K map. So you can definitely see the colors are similar, but the quality, of course, is lower. But this is more consistent and usable in color. Then we export them again and open it back in Unity. So in Unity now you should have the correct normal map. So we don't have these edges anymore like we see here, these weird artifacts, just because the normal had some wrong information. So now we have the correct result. So that was it for this part. I hope you enjoyed it and thank you for watching.